Hi everyone, welcome to this new lecture of fluid mechanics. In this lecture, we'll discuss regarding the flow through parallel pipes. In our previous video lecture, already have discussed few things related to the flow through series pipes or the number of pipes which is connected in a series and flow through a equivalent pipe. So now we'll discuss about the flow through parallel pipes. So to make it to draw this parallel pipes, first we need to draw a main pipe, so that from the main pipe is supposed to be divided into branches of pipes. Then that branches of pipe is called as parallel pipes. So what I'll do, let me draw a diagram for this. So suppose this is the pipe is there, and the pipe is converted into two branches of pipe, and again joined together to in the downstream region like this. Okay, so similarly let's draw this one also here. Again it will be divided into branches of pipes. Now here just I have drawn like that. In middle of that I'll just divide this one. Okay, and here also let draw like this, and in middle, as I told you, let make it two branches. That means yes. Okay, now if you see the fluid which is coming inside through this pipe, okay, this is the inlet of the pipe. Suppose this is the inlet of the position, inlet, and this is the outlet position of the pipe. Now when the fluid is coming inside, if you can see with a flow rate of suppose q is there, and with a velocity of some v will be there on that. Now this flow rate, okay, this flow rate q is divided, okay, you can consider the q or you can consider the v. Both are same because we know that q equal to av, so that we can calculate if velocity is given and diameter will be given, we can easily calculate the q, the rate of flow. Similarly, so we can consider the velocity or we can consider the q, the rate of flow. So this rate of flow or this flow is divided into two branches here. This is one branch and this is another one branch. Okay, in these two branch, again after that, after few after few length or after a few dimension covered of this flow, so these two are called parallel pipes. After few things, again it is joined in the downstream regions or the end regions, you can say. And here also the same q is coming out. What is the q was here? Okay, the same q is supposed to be come out from the pipe. So when it is divided into two branches, so here we can consider this is suppose q1 is there or q2 is there, and here suppose q1 is there. Okay, this q is divided into q1 and q2. For this q1 and q2, so this is also having some length is there and some diameter will be there, and here also this pipe will be also same, that length will be there and some diameter will be there also here, as well as per the diameter we can say the velocity also will be changed. Okay, so this is the length L1 and this is the length L2, and here also we can mark the diameter of this pipe is D2 and this is the diameter of the pipe D1. Diameter may be different, this pipe and this pipe diameter may be different, but mostly the length should be supposed to be same, because the length from here where it started to the end, it should be both same for that pipe 1 and pipe 2, we can say. This is suppose pipe 1 and this is pipe 2, the branch pipe 1 and this is branch pipe 2. So here also the velocity also will be considered, can be considered v1, and this is velocity considered can be v2 for this one. Already q2 I have mentioned here. If you want to mention another part, that also you can mention it. Okay, now here what we need to consider, now see the discharge through the main pipe, the discharge through the main pipe, okay, is connected or increased by connecting the pipes in parallel. That means here what is the discharge is there, now it is split it into two parts again. Okay, the discharge was split it into two pipes, so here the velocity will be different based on the pipe diameter. So after covering this one, again it is joining here. Now for this we can write the rate of flow in the main pipe, that is equal to, so we can write the rate of flow of the main pipes, that is equal to the rate of flow, or the sum is equal to the sum of rate of flow of the branches pipe, two branches pipe. That means Q equal to Q1 plus Q2, because these two pipes are joined in the parallel connection. So Q should be equal Q1 and Q2. Then we can write for this particular type of arrangement, in this particular type of arrangement, what we can write, that the head loss in the pipe 1, the loss of head in the branch pipe 1, so that one we can write HF1 should be equal to HF2. Head loss in the branch pipe 1 should be equal to head loss in the branch pipe 2. So what is the formula for head loss in the branch pipe 1? Because here you can neglect the minor losses, only you can consider the major losses. So that is nothing but 4F1 L1 V1 square divided by 2D1G equal to, here we can write 4F2 L2 V2 square by 2D2G. Now here minor losses are ignored or not taken. So this is about the major losses or the head loss due to the friction. This is the major loss concept. Now here if you consider the coefficient of friction, now here these terms already we have discussed previously. Let me again tell you. F is the coefficient of friction, L is the length, V is the velocity, D is the diameter, G is the gravity of that. So now here if you consider F1 equal to F2 in terms of F, or we can just write the coefficient of friction are same both for this pipe and for this pipe, let consider same, then we can write this equation. So let's cancel all the things. We can write L1 V1 square by 2D1G, and here we can write L2 V2 square by 2D2G. So what I did, 4 cancel. Again F plus F1 plus we have written, or we can write just F only. No need to write F. If you can consider F1 plus F2 or this F2 plus F2, so both will be cancelled here. Okay. Now again we want to cancel this 2G part also. You can cancel that. So that one will get L1 V1 square by D1 equal to L2 V2 square by, this is D2. This is the final equation of this. Okay. So if any data are required from this, like length will be given, velocity will be given, I need to find out the diameter of this pipe 2, branch pipe 2. So from this equation we can find out, correct? So velocity is supposed to be given for this one, or velocity not given, then Q supposed to be given, the rate of flow supposed to be given. So from that we can find out the other velocity, because we know that continuity equation A1 V1, or we can write this is A2 V2. So this is the theory regarding the flow through parallel pipes. This is quite simple, like two pipes are joined in the parallel connections. So one more pipe also you can join it here. So in that case we have to write how much pipe we want to join. You can join there. There we need to just add all this one pipe, and the flow rate will be also same by summation of all. The total flow rate of QE is equal to nothing but all this flow rate of the branch pipes. Okay, you can just increase how much pipes are there, you can increase on that. And if you want to find out the diameter or velocity or length of that particular pipes, you can also find out by using this formula. Okay, I hope you understand this theory part. If you are having any doubt regarding this, you can give a comment in the comment box. Thank you all.